Hey, how's it going today, AP Physics? Just want to do a quick instruction of how to do today's lesson, and then you could just jump right into it. So today we're going to be working on some practice problems, working on some graphical motion practice and Khan Academy. Homeworks are all going to be due on next on the 27th, so just go ahead and get that done by then. So as far as today goes, I would say, first of all, go ahead and get ready by having your AP formulas ready to go. And also, let's take a look at Khan Academy. You can work on this at the end of class if you're finished with today's lessons. But first thing I want to do is just kind of go over the kinematics practice problems with you, give you some pointers and point to some answers. Then I also want to review how to do question number 23. Work on these first before you get into the kinematics graphing motion practice. Okay, so to get into today's kinematics problems, we're going to go ahead and just review the work we did last time. Pretend I stamped your paper. There you go. Okay, let's take a look. I'm just going to get on the sideboard here and work it out with you. All right, so notice in this first question right here, we're asked to say an object is released from rest in a gravitational field. How far does the object travel between the third and the fourth second? So in these types of questions, it's always just actually assumed that there's no friction playing. They'll actually add friction. They'll tell you about friction if that is the case. But notice in this case right here, you're using the formula for distance is equal to VOT plus 1/2 AT squared. And in this case, because we're dropping it from rest, you can just cross that off, and it just says distance equals 1/2 AT squared. So really what we're doing is during the fourth second, we're just saying that's from second 3 to second 4. If you just calculated this 1/2 AT squared, and for the fourth second, for 4 seconds, and then you did the same thing for 3 seconds, okay. That's just going to tell you how far you went during that 4 seconds. So that's where that is. It's just a minusing problem, and you'll come up with your answer on that one. Okay. The actual answer for that one turned out to be, where is it actually? It's right over here. That one turned out to be C was your answer. Okay, so that was for number 17. All right, the next one here. This is using a acceleration, saying the ball is thrown upwards with a speed of 5 meters per second. Using the acceleration is equal to change of velocity over time. And you're just going to go ahead and solve for time in this case. Gravity is your acceleration. You've got your speed here, and then the final speed would be 0. So what you want to also notice is time up plus time down is your total time. Okay, and that's going to be 1 second. Okay, so there's the next one. Next one here, you've got a tennis ball released from rest and it falls vertically through a small distance in the air. What is the change in the speed of the ball and the change in the acceleration of the ball as it falls? So this one here says in the air, and it doesn't say anything about friction. So this is actually using friction. And you kind of have to understand none of these would work if we're just talking about free fall situation. So using friction, it's going to be this as your answer. You can go ahead and explain why that's the case. All right. Next one here is showing you a graph shows the variation of speed with the object as a function of time, which graph shows you the distance traveled. Okay. So notice in this question right here, we have got a curve forming. This is your answer. But go ahead and talk with your partners. Why, when we have a slope here, would we have a curve here? So talk with your partners and see if we can figure that one out. That's your answer to that. All right. This one here, we notice that there is a slope. Slope. There's always a slope. That means the truck must always be accelerating. Why is that? So go ahead and explain that one. Obviously, the word slope is an important part of your explanation. Okay, what does the slope of VT mean? Next one here shows a body moves in a straight line, which graph shows the variation with displacement over time if the object is experiencing a negative acceleration. Okay, so noticing that these are all displacement time curve is what shows you an acceleration, and which one is showing you a negative curve. Okay, you go ahead and explain that with your partners. Okay, all right, so next one here, this is actually the FRQ we're going to work on today. So this one is simply a matter of plotting information that they give you, and then determining using areas under the curve or slopes what they want. And so notice for a velocity time graph, VT, the area under the curve is equal to displacement. Whereas your slope of a graph like this is equal to acceleration. Okay, so those are your two key factors. The next thing you're going to do with this problem right here is you're actually going to plot the information. So notice, like, if I have -4 velocity at time equals 0, I just go to time equals 0 and go to -4 and plot a point. And then the next one, I'm like, at time equals 1, I'm at -2. So here's time equals 1, here's -2. I connect my line right there. Okay. Now the thing to notice now is once you've done that all the way through, you have this 0 line right here. Okay. Any of the areas that are under the line right here, like that, those are going to be negative areas. And any of them that are above the line are going to be positive areas. Okay. And when you think about displacement, you're going to have to be adding and subtracting these numbers, not only to fill in the rest of this information right here, but also to answer the question about where the car is going to be at certain periods of time. Now, that's basically what you're doing. You're also going to be taking slopes to answer questions about acceleration. Okay, so that's the basics of this. The last piece of this assignment here, then, is going to translate your slopes into straight positive constant values for acceleration. These are going to be constant values of acceleration because the slope of your VT graph is going to be an actual acceleration that you can calculate. Okay, so that's basically how you're going to do those. So you want to finish this whole setup today. The whole thing's going to be due on 9/27, but I think you can get it all done today. And then the next step you'll do is then get into the graphing motion practice that I had talked to you already about last class. As you get into these right here, you're going to answer all the questions, but I want to notice that on the upcoming slides, including the areas underneath here, I've gone ahead and given you hints for every other problem. Okay, so I kind of worked them out for you. And so if you're ever having any struggles, I've got all kinds of stuff to help you out to figure it out. So yeah, so that's it. You're going to be working through this lesson today. You guys have a great day. If you have any questions, just save them for me. We'll have a big discussion on all this on 9/27. So have a great day, guys. Goodbye.